Here we're going to look at how to solve equations when you have to complete the square first. We've got a quadratic trinomial here, and we know we have to complete the square because there is no factors of 2 that add to minus 4. So we can't use our normal factorising for trinomials, so we need to complete the square. So let's go through that. X squared, take 4x, then to work out what goes in the middle, your little think bubble here would be saying that I'm going to halve the middle term and then I'm going to square it. Half of minus 4 is minus 2, squaring that, 2 squared is 4. So what I need to do is add 4 on, then of course you take the 4 away, and I've still got my plus 2 equals 0 tacked on the end. We'll deal with those later. I've now made a perfect square, so that becomes the square root of x squared is x, the square root of 4 is 2, and this sign goes in the middle here. So x minus 2 all squared. Minus 4 plus 2 is minus 2 equals 0. So I've completed the square here. Now the way you solve this from now, you could take one of two paths, and I'm going to divide my page up. If I want to continue with my factorising, I could do my dots. So I'm going to write this as x minus 2 all squared minus root 2 squared equals 0. Factorise that, x minus 2 minus root 2, x minus 2 plus root 2, and then use the null factor law. I know that either x minus 2 minus root 2 equals 0, or this right bracket x minus 2 plus root 2 equals 0. Then I would need to solve each one of those. So my minus root 2 I'm going to put over here and make it a plus. My minus 2 is going to go over there and become a plus. So x becomes 2 plus root 2. For this one, my plus root 2 will head over there and become a minus. My minus root 2 will go to the right and become a plus. So x equals 2 minus root 2. So there's my two solutions, and if you remember back to previous lessons, these two will then tell us what our x-intercepts are. We'll learn later about how do you place those onto your axis. Where is 2 plus root 2? Where does that actually go? We'll look at that at another time. Another option that you could do if you're not comfortable with dopsing is that you could just go straight from here and straight from that step there and do some backtracking. So I have x minus 2 all squared, take 2 equals 0. Then my minus 2, I'm going to move over to the other side, so I would have x minus 2 all squared equals 2. I now need to get rid of my squared up here. Opposite of square is square root, so I square root both sides. But you've got to remember that the square root of 2 could be positive root 2 or it could be minus root 2. You need to consider both the positive and the negative root. Then I've just got to get rid of this minus 2, and I would do that by adding it. So I would have 2 plus or minus root 2. And I've actually got exactly the same solution. 2 plus root 2 is here, and 2 minus root 2 is here. The same solution whether you do it using dots or whether you do it using backtracking. And I don't care which way you use, because provided you do everything correctly, you'll get the right answers. Let's try another one. Here we go. So first of all, I'm going to complete the square, and again I'm going to think about my middle term, halving it and squaring it. Half of 6 is 3, 3 squared is 9. So I'm going to x squared plus 6x, then I'm going to add 9, take 9, then I've still got my minus 11 equals 0. Here's my perfect square. So I take the square root of x squared, I take the square root of 9, and I take the sign from there. There's my perfect square. Minus 9 take 11 is minus 20 equals 0. Again, you can decide which way you want to go from here. Let's look at both. If I want to DOPS, I'm going to do x plus 3 minus root 20, x plus 3 plus root 20 equals 0. Then null factor law, x plus 3 minus root 20 equals 0. Or, just so I can fit it in, I'll put it down here, x plus 3 plus root 20 equals 0. You need to take your root 20 over, you need to take your 3 over. So x is going to be minus 3 plus root 20, remembering that root 20 can be simplified into 2 root 5. Remembering your work with surds. If I have this one down here, I'm going to have x equals minus 3 minus root 20, or I'll write that as 2 root 5. So there's my two solutions, minus 3 plus 2 root 5, minus 3 minus 2 root 5. If you don't want to use DOPS, but just use backtracking instead, I would have x plus 3 all squared minus 20 equals 0. Take my 20 over there, x plus 3 all squared is 20. Square root both sides, remembering to take the plus and the minus root. And then my plus 3 heads over to this side as a minus 3. And then, of course, simplifying that root 20 to be plus or minus 2 root 5. Same answer, minus 3 plus 2 root 5, which is here. Minus 3 minus 2 root 5 is over here. Same solutions, two different methods, totally up to you as to what you want to do, which method you want to do. If you have something like this one, where you complete the square, so if we go through this method here, I've got half of 6 is 3, 3 squared is 9, so I add 9, take 9, and I've still got my plus 12 equals 0. Here's my perfect square. Take the x from x squared, the square root of 9 is 3, this sign comes down. Then minus 9 plus 12 gives me plus 3. Now if you recall when we were doing our difference of perfect squares and completing the square, if we have a plus 3 we can't DOPS it because a DOPS needs a difference of perfect squares. A DOPS has that minus sign on it. If it doesn't have a minus, then we can't actually use that rule. And in previous exercises I just told you that it can't be factorised and you'd stop. This is further illustrated if we do our backtracking method here. So if we get this far and I've got a plus 3, I take it over to the other side, it becomes a minus 3. Then my next step would be to square root both sides. So you try to square root a negative number. Of course you can't do it. There's no number that when you multiply it by itself twice you get a minus. It doesn't work because 2 minuses make a plus, and 2 positives also make a plus. So you can't actually solve that. There are no solutions. And what that means as far as graphing goes, that when we get up to graphing the parabolas, it's going to mean that there's no x-intercept. You can see here that the graph is sitting up above the axis, doesn't cut the x-axis at all, so there are no solutions. There are no x-intercepts.